In this presentation, we want to look at creating objects and accessing or using that object's fields and methods. Creating the person class. For this series of slides, we'll use the person class again. So let's review it. Public class person, and it has two instance variables, a string for the name and an integer for the age. So every person object that we create has a unique name and age. We have a constructor. The constructor has a header, public person, string n, and int a. So these are parameters here. This is our parameter list. And n is going to be used to initialize the name field, and a is going to be used to initialize the age field. Instance variables are also called fields. We also have a method, and it's called an instance method because it's not static. And it's called say hello and returns void. Void just means that we don't have to have a returned value. System.out.println, hello, my name is name. You can see that the instance variable is accessed from here. And that's because the scope of these instance variables fall throughout the class. How do we make an object? We make an object with the new keyword. Whenever you see the new keyword, you are calling the the class's constructor. A constructor is a method, and its name must be followed by round brackets or parentheses that look like this. Just like every other method, the values supplied inside the round brackets must match the parameters in the class's constructor. Parameters must match in both type, such as a string, int, double, etc., as well as the number of arguments, just like regular methods. Making a person object. Every person object will have all the fields or instance variables and methods defined in the class. Each object's instance variables will have actual values, the values of the parameters we supply when we create a new object, or as it's called, call the class's constructor. So person P, we've declared P, our variable, to be a person type. Notice how we use the class name for that. And then we set it equal to a new person. So here's our new keyword followed by the constructor. This is a call to the constructor, and the name for this person will be Rhonda, and she is 15. The line above initializes the instance variables for the person object called P to Rhonda for the name and 15 for the age, creating a new person object. You can see this process very nicely in BlueJay's Workbench view. In BlueJay, you can see the classes, and they look like this. If you right mouse click the class, you can call the class's constructor. There it is with the keyword new. That'll open up this window, and it gives you a chance to name the object. So this instance will be called person1, and provide values for the parameters. So Rhonda will be the string for the name, and 15 will be the int a for the age. Once the object is created, it will appear on the workbench, which is right here. Double-click on the object that appears to view its state. And this red box will pop up, and the value of its instance variables are shown. Its string name is Rhonda, and its int age is 15. Right-click on the object to view its methods. So right mouse clicking will pop up this context menu, and you can see any methods right here that you can call. So calling the say hello method on the P variable would output hello, my name is Rhonda. The picture below demonstrates how to make an object with Java code rather than relying on BlueJay's GUI and Workbench. So you can create a separate class, public class runner, and this runner class can have a main method. So this is your typical public static void main string args method. In here, we can create a person object. So person P equals new person, pass in Rhonda, pass in 15. And then you can call its methods by saying p.hello, say hello. So that's just a call to the say hello method, and it will print, hello, my name is Rhonda. So how is an object made? The syntax for making an object follows this general sequence. You write the class name, the object name, equals new class name, parentheses, some parameters. The name of the object is just a variable name. This would be a variable name and should follow normal Java naming conventions. An object is a particular instance of a class where all the instance variables have actual values. But how can the content of an entire class be saved into a variable? What is an object? Well, suppose you had a cat class. So public class cat, string name, string breed, public cat, string n, string b. This is the constructor header, and it takes in those string and the two strings for its name and breed, and it's assigned here. Suppose we declare only two cat type variables. So cat C1, cat C2. C1 and C2 are cat type variables, and their values will be a reference to a cat object. However, they haven't been initialized yet. So these are just declared variables. There aren't any actual cat objects yet. An object or a custom type variable that hasn't been initialized has no object yet to refer to. C1 and C2 have been declared as type cat, but they don't yet refer to an actual object. Given that C1 and C2 have already been declared cat type variables, how do you initialize them? Well, look at this. C1 equals new cat. This cat is called Fluffy and is a Siamese cat. C2 is a new cat with the name of Muffin and a breed of calico. C1 and C2 are cat type variables. Their value is a reference to a cat object. A cat object is a software bundle of all the fields and methods declared in the cat class, and the instance variables have actual values. So this cat's Fluffy, this cat's Muffin. Each cat has a name, but its names are different. The variables C1 and C2 store a reference to a place in the computer's memory where all the information about that cat object is stored. So C1 points to a cat whose name is Fluffy and its breed is Siamese, and that cat can say meow. C2 points to a cat, and in memory, its name is Muffin and its breed is calico, and it can also call the meow method. Saved inside the C1 and C2 variables are references to the cat object stored in the computer's memory. Are you confused yet? This link has a really excellent explanation of variable types. A variable of a custom type value is a reference to where that object exists in memory. In fact, classes and objects are actually referred to as reference types, as opposed to primitive types. In contrast, the value of a primitive type variable, like an int, double, or boolean, or char, isn't a reference, it's an actual value. A custom type, like a cat, isn't a single value, it's a bundle of variables and methods. The syntax for this may be confusing at first, but let's compare to the variable initialization we've been doing nearly the entire year. So if we wanted to create a primitive type, we would say int apples equals 12. The type, the data type is an int, the variable name is apples, and the value is 12. For the person, the type is person, the variable name is p, and we would call the constructor here. And this is the value that the p object is referring to. Wherever this information is stored in memory, p will point to this object. A class is a custom data type and a blueprint for objects. A variable of that type stores a reference to an object of the class. If you have a class called person with a string name and an int age, the value of a person type variable will be referenced to a person object that will have a particular name and age. So person p equals Ron. What? This is no good. A person variable cannot store a string. Person p equals new person. The p variable is now storing a reference to the person object with the name of Ron and the age of 15. Hopefully at this point, you have at least a vague understanding that an object is a bundle of variables and methods. The instance variables or fields describe what the reference type is, and the methods describe what the reference type does. So you made a person object. Great. Now what? You probably need to interact with the object in some way, assuming you're using the objects to solve some problem. We use the dot notation to interact with objects, something you've already seen in the PowerPoints and have been using all year long. Dot notation syntax is used to access the fields or instance variables and methods that belong to an object. Remember, an object is a specific instance of the class with actual values for the instance variables. So person P equals new person, Rhonda 15. You could print the value of the name field of our person object called P like this: system.out.println p.name. When I say dot, this is the dot operator, or this you might call this the dot notation. And P is our person for Rhonda. P.name would give us Rhonda. The code above would print the value of the name instance variable that we initialized for that particular person. Some more examples working with fields. So person P1 equals new person Tom, who's 15. Person P2 equals a new person named Tina, whose age is 17. If we want to print P1's name, we would say P1.name in a print statement, and that should print Tom. Likewise, if we printed P2.name, it would print Tina. If we had an integer total ages, we could set it equal to P1.age plus P2.age, and their total ages would sum to 32. Every person object has a name and an age, but the value of the fields will be specific to each object. Calling the say hello method. We can also access the methods of an object with dot notation. Every person object has all the fields and instance variables and methods for the person class. To call the say hello method on a person object P, we type the name of the variable or the object, which is P right here, a period, also known as the dot operator, then the name of the method, say hello. And if we needed to put any parameters, we would type some values here. This one doesn't take any parameters, so when we executed this code, the call to say hello would just print, hello, my name is Rhonda, or whatever the object's name was. The line above is calling or running the method defined in the person class using the person object P. So say hello has no parameters. The say hello method is an instance method and must be called on an object. The dot notation should look familiar. Recall the string methods we've been using for some time. Remember that we're calling on strings, examples. So string str equals hello, and we could say str.substring1. So we are using the dot operator when we use the string objects. Given that we know that the dot operator is used to call methods on objects, it just so happens that strings are objects. Note how string is uppercase, a hint that it's a class right here, the data type string. Primitive types will have a lowercase first letter. Whoa! The string methods exist in the string class and are called on string objects with the dot notation. The value the method returns is based on the state of that particular string object. Methods will always have round brackets or parentheses after their names. The round brackets tell Java that something is a method, not a variable. For example, to access the name of a person object P, we would write p.name. This by itself is not a statement, but it is nice to know that you can access the name this way. To call say hello, the say hello method on a person object P, we would write p.sayhello, parentheses with a semicolon. This is a complete statement and is executable all by itself. So here's our class again. The say hello method shown above does not have any parameters. We can look at its parameter list in the method header right here. Also note, it can reference the name instance variable. The name variable's scope is the entire class. So the name is declared up here, but it is accessible from the constructor as well as any of the instance methods. Given the say hello method shown in the previous slide and the following variable declaration, so person P equals new person Ron 15, what would the output of the following method called be? P dot say hello. Well, it would be hello, my name is Ron, because P, this person object, its name instance variable was initialized to Ron. Suppose we make the following two person objects. P1 is Rhonda, who's 18, and P2 is a person called Ron, who's 14. Each object has a name and an age field, but with different values. Each is a specific instance of a person. P1 is an instance and P2 is an instance. Both have all the instance methods defined in the person class. They each have a name and an age, but they are distinctly different. Remember when you instantiated or created the person object, this is called an instantiation. When you call the constructor, you're creating an instance, and that's called instantiation. So when you instantiate or create a person object using the keyword new, you're calling the class's constructor. Creating multiple objects. A class is a blueprint for objects, any number of objects. An object is a specific instance of the class with a particular job to do. For example, when you create an object of the scanner class, that object has all the fields and methods found in Scanner. A scanner object has a specific job to do. For example, scan the console for input from the user. You could also use a scanner object on other things. For example, a string of text or a file object. Much more on that later. Working with multiple objects. Given the two person objects declared previously, remember P1 is Rhonda and P2 is Ron, P1.name would print Rhonda, P2.name would print Ron. P1 say hello prints hello, my name is Rhonda. P2.say hello prints hello, my name is Ron. P1.name equals Samantha. Change the name of P1. Now, when you print P1.name, it will now print Samantha. P2.name still prints Ron.